Hi, and good day everyone.
We are here to discuss the innovation of a mini air cooler using microcontroller and sensor.
Before we discuss our topic, I'd like to introduce my co-researchers. Emmanuel Padrigal, Florizel Atay II, John Edison Kenya, Nino Dinolan, and last, me. I'm Christine Leja and Igo. So next, I'm the first to lead our first topic. Hello and good day. I'm here to discuss our background and rationale about innovation of an air controller using microcontroller and sensor. First is beating the summer heat. To avoid the heat of summer, to make oneself cooler or go to the place to stay cool, especially during hot days in summer. 2. Occupies less space. An enclosed space is intended to be occupied by people for extended periods of time. 3. Air coolers utilize 80% to 90% less electricity. Smaller amount or quantity or storage is less of a problem than it used to be. 4. To ensure efficient transfer. Having the buffered space too far apart means that they may be cooler spots in the corners. 5. Use natural cooling. The use of ventilation or natural heat sinks for heat dissipation from indoor spaces. Fresh air or clean air cooler. When the clean air feature is activated, the purifier pulls impurities such as a pollen from the air. It literally cleans the air. And last, sensor system. It asserted signal processing hardware with the processing either in or on the same package or discrete the sensor itself. That's all of the background and rationale.
Mini air cooler is a device that uses the fan to blow hot air to the water soak pot. As the air passes through the pod, the water evaporates and cools the air. This cooler is to circulate into the room. For the development for this study, we address the following question. What design parameter should be considered to develop the mini air cooler? What development and implementation strategy should we adopt to be utilized and ensure that mini air cooler will work? What evaluation parameter should be assessed in order to measure the performance and acceptability for the mini air cooler?
Objectives of the statement. The brief of this paper seeks to develop the mini air cooler to be made relatively cost efficient, easier to control user interface, and effective automation to ensure high quality and quantity output from relatively small input. So here are the specific objectives of the study. First of the objectives is to design a relatively cost-efficient mini air cooler. Second, to develop mini air cooler with necessary equipment. And the last, to evaluate parameters to assist in order to measure the performance and acceptability of the mini air cooler. For our conceptual framework, we have the input, process, and output. For our input, we have the baseline research and the material. So, for the baseline research, the study to serve the purpose of informing the decision makers what impact of the project has had on the target community. Accordingly, along with the strategies such as use of control groups, it also helps in attributing change in the target population of the project. In the process, we have the system design and prototyping. And this time, we're going to plan the design of our project. Output. It is the complete data of prototype of the innovation of an air controller using microcontroller and sensor.
In this video, I will be discussing the review of related literature and studies. The first one is performance of mini air cooler on parked car under direct sunlight. As a result, the two cars have almost the same cabin temperature profile. the highest temperatures in car A and car B are 56.1 degrees Celsius and 54.4 degrees Celsius, which occur around 1 p.m. Meanwhile, the highest ambient temperature is 37.5 degrees Celsius at the same time as peak temperature occurs in the cabin. After 2 p.m., both cars experience a decreased temperature due to decreased sunlight intensity. The application of a mini air cooler placed on the dashboard with the power source of the solar cell placed on the roof of the car is able to reduce the temperature of the car cabin on average 6K compared to the cabin temperature of the car with the same specification or without air cooler. The second one is the design and fabrication of mini air cooler. The addition of fins to a heat sink increases its total surface area, resulting in greater cooling effectiveness. As the water flows inside the fin, the temperature of the fin material decreases, so the fingers which hits the aluminum fin also get decreased, and cold air which reaches the near people. The design of cooling fins is encountered in many situations, and we those examine heat transfer in a fin as a way of defining some criteria for design. The third one is the design and construction of a portable air cooler. The cooling performance of a portable cooling system mainly depends on the temperature and the relative humidity of air and the contact surface between air and water. The constructed portable cooling system reduces the temperature of the room by an average of 4 with normal water and 6 with cold water from the atmosphere. It showed better performance in the closed room, but relative humidity slightly increased than open room because the room was being saturated. The last one is the air cooler designed to face rising temperature outside the home. And this study discusses that after selecting the items through sketches and illustrations and determining dimensions, the following experiments makes adjustment to the implementation of the first sample material. And that's all. Thank you.
For today, I will give some common controls and functions of our research. Conceptual design. I would like to introduce myself first. I am John Edison Bikinya and I am a student of BSAMT 3V5. And we have condenser blower. The purpose of this condenser blower is to transfer heat into outdoor air to prevent overheating from our mini cooler. As you can see on your screen, we have a drawing example of our mini air cooler. We have on and off sensor, and also we have air filter. It helps to remove or absorbs solid particles such as dust, molds, and bacteria coming from air. We have compressor supplying high pressure clean air to fill gas cylinder. Suction accumulator is used to prevent liquid refrigerant flood back into the compressor. And last, we have a evaporator coil. Evaporator coil is basically absorbing heat coming from our houses. So that's all for today. Keep safe, guys, and God bless you all. Thank you.